For this example, we're given functions f and g. F of x is 7x plus 8 and g of x is 7 minus 10x. We're going to answer all of these questions. So starting with f, the domain of f, I'm just going to type it in so you can have something to go by. 7, y equals 7x plus 8, same as f of x equals 7x plus 8. You graph it, you're going to see a line. And the domain of this line, almost all lines, if you draw this line, or if you just look at it, how far left does it go? So you have to imagine the line. It doesn't stop. It keeps going forever to the left. Forever and ever to the left. And it goes forever and ever to the right. It never stops. So what that means is the domain is negative infinity to positive infinity. Since infinity doesn't exist, we'll use parentheses around those. Now the domain of g, I'll go ahead and graph that one. We'll just graph it as y2, 7 minus 10x. And it's also going to be a line. And for the same reason, it doesn't ever stop. Left or right, it goes forever left or right. So therefore, the domain is negative infinity to positive infinity. Those are not 8s, they're infinity symbols. Now, it's asking for the domain of f plus g. It doesn't really make much sense, even though it can make sense, to not find what f plus g is first. So let's go down here. We're actually going to go ahead and find f plus g of x. Now to find f plus g of x, I'm going to minimize that. To find f plus g of x, yeah, that's not a plus sign. Let's just do it right here. I probably should have had more room, but let's go ahead and just do it. All you're really doing is you're finding f of x plus g of x. Now f of x is 7x plus 8. And then g of x is 7 minus 10x. Now hopefully you know that all you're doing on this is combining like terms. So 7x minus 10x is negative 3x, and 8 plus 7 is 15. And so if you want to, you can go ahead and graph that. Even though we know what the domain is, we should know what it is anyway, because it's a line, and it's a combination of two lines whose domains were negative infinity to positive infinity. That's what we're going to get here too. So we actually have answered two parts. So f plus g of x is negative 3x plus 15, and the domain is negative infinity to positive infinity also. Now let's do f minus g of x, and I'm just going to erase to save some space. So it just means do the same thing, subtract. Now when you do subtraction, just be really careful. In fact, I'm going to do it the way, since you get to use the graphing calculator in most classes, I'm going to show you how you might want to do this. When you combine like terms, this is 7 minus negative 10. Do you see that? 7 minus negative 10. 7 minus negative 10. And you get 17x. And then you have 8 minus 7, which is a positive 1. And for the same reasoning, because it's going to have the same domain. If you want to graph it, you can always graph it and look left to right. That's all domain is. And it goes from negative infinity to positive infinity. That's not down to up we're looking at. We're looking left to right. So for f minus g of x, that's 17x plus 1, and the domain is negative infinity to positive infinity. Now we're doing f times g of x. So once again, just to save some writing, when you do f g of x, it's the same as f times g of x. I probably should have done this up here before. I didn't. There should have been a minus sign in the previous step. But it's f g of x the same as f of x times g of x. That means you're going to multiply it out. Full method, distributive property, however you want to look at it. Just take the 7x times 7, which is 49x. 7x times negative 10x, which is negative 70x squared. And then 8 times 7, which is plus 56. And then 8 times negative 10x, which is negative 80x. Go ahead and put it in correct order and combine like terms. This is my only x squared term, so I'm going to write it first. And then 49x minus 80x is a negative 31x. You can always use your calculator to verify if you need to. And this plus 56 is all by itself. And that's what's going to go here for all of this. So negative 70x squared minus 31x plus 56. With the domain, you might as well go ahead and graph it. So you have negative 70, I don't know why I'm using parentheses, negative 70x squared minus 31x plus 56. When you graph it, you're going to see a parabola, hopefully, and hopefully it's not off the screen. Let's try zoom fit. Zoom. I don't like this calculator too much. Let's just do zoom out. Want to? That's what happens. No, that's bad. Let's do about the zoom standard. Well, what it is, let me just graph it for you. It's pretty much a parabola looks like that. And how far left is it going? Forever and ever. How far right? Forever and ever. So the domain of f times g of x is also negative infinity to positive infinity. Now we have the domain of f times f. So I'm going to erase all of this. And that may give you some time to catch up a little bit if you're trying to keep up. That's okay. You can always pause and rewind my videos. I'm actually going to go ahead and erase all of that. So now we're doing f times f. That's just f of x times f of x. And what was f of x? 7x plus 8. So we're just going to take 7x plus 8 times 7x plus 8. 7x times 7x is 49x squared. 7x times 8 is plus 56x. 8 times 7x is plus 56x. 8 times 8 is positive 64. Combine your like terms, we have 49x squared. 56x plus 56x is probably 112x plus 64. And then that's what goes down here. 49x squared plus 112x plus 64. So let's just graph that one. We probably won't be able to see it. In fact, I'm not going to worry about it because I know that since it's a positive x squared term, it's going to look something like that. And when you go left or right, it goes forever to the left and it goes forever to the right. So that's the domain of that one. It helps to know the basic shapes looking at the first term. And now we have f minus g of x and g over f of x. And I may have cut this one off. And then again, I may not have. But I'll go ahead and find the domains of both of those, just in case. After we find what they are. So f divided by g of x. And all this is nothing but the f of x function on top and the g of x function on the bottom. And the f of x function is 7x plus 8. And the g of x function is 7 minus 10x. And I can't simplify that. So that's what this equals. Now the domain, I'm going to graph it so you can see how ugly it actually looks. When I graph it, I'm going to put the numerator in parentheses. I'm going to put the denominator in parentheses. That's how you want to type it in. And look at the graph. Now, as you can tell, it's going forever to the left and it's going forever to the right, but there's something going on in the middle. There's a point that's not getting to. There's actually a vertical asymptote there, an x value that doesn't exist. And the way you find that, you basically take your denominator, which is 7 minus 10x, and set it equal to 0, because it can't be equal to 0. You can't have division by 0. So your denominator cannot equal 0. Now, when I solve this, I do it differently than most people. If I have a negative x term, I like to add that x term to both sides to make it positive. So I'm solving it as if it weren't equals, it just can't be equals. And then divide by 10. And that means I'm going to switch the numbers around, so I get x is not equals to 7/10. Now, if you want to check that, if you go to trace, type in 7 divided by 10, and hit enter, you won't see an answer there. That's how you can check it on your calculator. So what that means is that my domain, let me bring up the graph again, it goes forever to the left, and it can't get to 7/10, and it goes forever to the right. So kind of a way to think about it is, let me see if I can draw it over here. It goes forever to the left, and then at 7/10 it doesn't exist, and then it goes forever to the right. So what that basically is, it goes from negative infinity to 7/10, parentheses around both, and then union, it jumps over to 7/10, that's why I'm using parentheses, and it goes on forever to positive infinity to the right. And then the last one that we're going to look at is the domain of g divided by x. And now that is, we just flip everything over. So g over f of x is the same as g of x over f of x, and g of x is 7 minus 10x, and g of x is, or f of x is 7x plus 8. So I'm actually going to do the same kind of reasoning, and I know it's going to have that basic kind of shape. Let's just go ahead and graph it. Can't hurt to graph it. 7 minus 10x in parentheses divided by, open parentheses, 7x plus 8, close parentheses, graph. Go to, error. Where's my error? Oh, I didn't have parentheses. Second, delete, which is insert parentheses. Watch my mistakes. You may learn some stuff about the graphing calculator. But once again, you'll see that there's something not good going on in this part. It goes forever to the left, forever to the right, but there's something bad here. So we know that the domain is going to be negative infinity, comma, something, union, something, comma, positive infinity. How do we find that something? We take that 7x plus 8, can't equal 0 because that's our denominator. Subtract 8 from both sides. You get 7x equals negative 8, divide both sides by 7, and that's why x cannot be. And that's what we put in here. They almost always follow the same kind of pattern. It just depends on maybe like an x squared is involved or something like that. Check it, do trace, negative 8 divided by 7, enter, no value. And that's what you're doing.